Hello everyone, welcome to online lecture series of electronic devices. Here the subject code is KEC301. I am Dr. Sapna Katiyar, Professor in Electronics and Communication Engineering Department at ABES Institute of Technology, Ghaziabad. This is lecture number 19 and today's topic is PN junction diode. So in today's session, I will be telling you about the PN junction and then I will discuss about the PN junction diode, because once you will be able to understand what is PN junction, how it forms and what are the characteristics, the properties, then you can clearly define and explain a PN junction diode and you can explain its behavior as well. So let us begin with the PN junction. What is PN junction? See, you have studied about the semiconductors. Basically, depending upon the impurity, see, there are two types of semiconductors. The classification is, one is the intrinsic semiconductor, other is the extrinsic semiconductor. Intrinsic semiconductor is the pure semiconductor and extrinsic where some impurities is being added. So, before telling you about the PN junction, let us take a review, a recap about the extrinsic semiconductor. See, in case of extrinsic semiconductor, I have discussed that there are two types of semiconductors. One is N-type semiconductor and second is the P-type semiconductor. So, depending upon the type of impurity, which type of impurity is being added, the type of semiconductor is being formed. If we talk about the P-type semiconductor, it means if you are having a pure semiconductor and a trivalent impurity is being added, then a P-type semiconductor is being formed. Trivalent impurity which are having 3 valence electrons. So, in that case, what is going to happen? In the case of P-type semiconductors, the majority charge carriers are holes, electrons are in minority over here. At the same time, because there are some acceptor ions, means they have a tendency to accept the ion and complete the shell. So, in that particular case, negative acceptor ions. Why negative? Because they are accepting it, acceptor ions. And when we talk about the N-type semiconductor, so in case of N-type semiconductor, if a pentavalent impurity is being added, pentavalent impurity, the examples are nitrogen, phosphorus. So, each and every impurity atom can contribute one free electron. So, in case of N-type semiconductor, the majority charge carriers are electrons, holes are in minority. At the same time, because each and every pentavalent impurity atom is capable to donate one electron. So, they are having donor ions because they have a tendency to donate, that is why positive donor ions. So, this is how you can explain what is P-type semiconductor and what is N-type semiconductor. Now, when we are talking about the PN junction, this PN junction, it means junction, there is some like point, bridging point. So, if you join a P-type semiconductor with a N-type semiconductor, like these two pieces, if you join, but joining doesn't means you are just attaching. There are some special fabrication techniques via which this like P-type semiconductor can be joined with the N-type. So, in that particular case, at the boundary, a junction is being formed, that is known as a PN junction. You can see in this particular diagram. Here, a P-type semiconductor is being taken which is joined with a N-type semiconductor. In case of P-type semiconductor, you can see majority charge carriers are holes, minority charge carriers are electrons, while in N-type semiconductor, majority charge carriers are electrons and minority charge carriers are holes. So, when these two are joined, then this joining point, this boundary is actually a junction, and this particular junction is known as a PN junction. So, a PN junction, it is a boundary or interface between the two types of semiconductor materials, as if you are joining a p-type semiconductor with a n-type semiconductor. And since p-n junction makes a versatile device, because of this you need to understand its behavior and what are the special fabrication techniques, how a p-n junction is being formed. You need to understand, because you have to study a number of devices in your electronics on the basis of these semiconductors. So, this is how you can explain about a p-n junction. Now, what is depletion reason formation? You are going to listen this particular term number of times. You may get a question in your university examination. What is this depletion reason? What is this depletion layer and how it is actually being formed? See, as if when we are talking about a p-n junction, means when p reason, p-type semiconductor is joined with n, this is the point, this is the junction actually. Now, what is going to happen? As if I have told you that in case of p-type semiconductors, holes are in the majority, and in case of n, electrons are in the majority. Here electrons are in minority and here holes are in minority. Now, what will happen? Because in this particular region the concentration of holes is very high and here the concentration of electrons is very high. Now, what is going to happen? There will be a diffusion of electrons and holes across this particular junction. It means holes which are in the majority in p-type region, these holes will move towards n region, and electrons which are in the majority in n, they will move towards p region and they will recombine. See, holes are moving from p to n, will recombine with the electrons, electrons are moving from n to p, will recombine with the holes. Now, what will happen? After a certain time, because after the recombination of electrons and holes, they will disappear, but after a certain time across this junction, on the left hand side, you can see these negative ions, acceptor ions will be deposited, while on the right hand side the donor ions, because in the case of p type the immobile ions are the acceptor one, while here the immobile ions are the donor. So, across this junction after a certain time there will be a accumulation of immobile ions, acceptor and donor, like here you can see in this particular region. So, what will happen? This accumulation of the immobile ions across the junction will further stop the diffusion of electrons and holes across the junction. This is actually the depletion region, this region which contains the negative and positive ions. So, this is how you can explain the depletion region formation. So, the region having uncompensated acceptor and donor ions, this particular region, this is the depletion region. And there are some very important points you must remember. This depletion layer, depletion region, depletion zone or junction region, or it is also known as a space charge region. Why space charge? You can see in this particular region negative and positive ions have been accumulated, that is why space charge region or space charge layer. And the width of depletion region depends totally upon the doping of the semiconductors. Higher the doping, more number of charge carriers, more number of charge carriers means holes in p and electrons in n type semiconductor. So, higher the doping, lower the depletion width. This is how you can explain the depletion region formation. Now, the second term, the very important term, which is the barrier potential. What is this barrier potential? See, the same case we are discussing about a p-n junction diode. This is the junction. Now, when there is a formation of the depletion layer, this is the depletion region. Now, when this depletion region will form and depletion layer will form, what is actually happening? A electric field is being developed across this particular region, which will further stop the diffusion process, and this particular electric field is known as a potential barrier. So, here you can see due to the presence of immobile ions, across this particular junction, electric field is created, and this electric field is known as a barrier potential or junction potential, or it is also known as a cut-in voltage. So, because of this particular barrier potential, see, further diffusion will takes place only when the applied voltage cross to this particular barrier potential. See, if you talk about the silicon, the barrier potential is 0.7. If you talk about the germanium, there is some other value. So, accordingly, this is how you can explain the barrier potential. Now, let us discuss about the energy hill, energy band diagram of a PN junction. You have studied about the energy band diagram of intrinsic semiconductor, you have studied about the extrinsic semiconductor. Now, how it looks when we are talking about a PN junction, how the energy band diagram looks like for a PN junction, and there is a concept of energy hill which I shall be discussing over here. So, in this particular manner you have to understand it. See, in case of when you have to just let me tell you, when you have to plot the energy band diagram, what happens over there? There is a valence band, there is a conduction band. In between the valence band and the conduction band, there is a band gap. Similarly, when you are plotting for P region, when you are plotting for N region, there must be difference in the levels of conduction band, difference in the levels of valence band. You can see over here, this is P region, this is N region, P type semiconductor, N type semiconductor. When a P type semiconductor is being joined with the N type semiconductor, and when we are observing, when we are plotting the energy band, here you can see this is the valence band, this is conduction band, but in this particular diagram you can see the valence band and the conduction band of N region. This is slightly lower than P. Conduction band and valence band of P region is slightly higher than N. Why? It is only because of the difference in the atomic structure, right? So, you must remember it while plotting the energy band diagram. Now, you can see this is the situation when the junction is being formed, means when the two different semiconductor materials have been joined. This is that particular case, and here you can see in case of N type semiconductors, the majority charge carriers are electrons, and here conduction band is filled with majority carriers which are electrons, and there are few holes which are in the minority in the valence band. For P type semiconductor, majority charge carriers are holes. So, here you can see this valence band is filled with the majority charge carriers which are holes, and some minority charge carriers which are available over here. Now, what is happening when you have joined just, then you know that there, because of the difference in the concentration gradient, diffusion process will take place. Why the difference in concentration gradient? Because here electrons are in the majority and here the holes are in the majority. So, when these two have been joined, now what will happen? You can see there is some portion which is overlapping in between these two bands. Like here also, in the case of conduction band, in the case of valence band, you can see this overlapping region. So, what will happen? Electrons which are in the majority, they will be moving from conduction band of N region to the conduction band of P region, and then they will be losing some of the energy and will be falling to the holes which are available in the valence band. I hope now this particular point is clear. Electrons which are moving, crossing the junction, and they are dropping out to the valence band by losing certain amount of energy. Now, what will happen after a certain time? Because electrons are moving from here to here and they are losing certain amount of energy. So, after a certain time, because of this diffusion process, you can see the energy level for this conduction band will be dropped down. Obviously, when the electrons are moving from here to this and crossing this particular junction, it means now energy level of N type semiconductor, energy level of N is being dropped down in comparison to P. So, you can see in this particular case, which is at the equilibrium. When further diffusion will stop, then you can see this is the conduction band, this is valence band, and you can see this level and this level, this level, this level, means there is a difference in energy. Now what will happen at this particular equilibrium, when electrons have to move from the conduction band of n region to the p region, they have to climb a hill. This is the concept of energy hill, because now electrons have to climb this hill, then only they will be able to reach to the conduction band of the p type semiconductor. It means at equilibrium you can observe, because of the energy gradient, this acts as an energy hill, and now these electrons will be climbing this hill, and this is the concept of energy hill. And for the PN junction, you can explain with the help of these diagrams. First you have to explain at the junction, then what is going to happen at the equilibrium, means before the diffusion start and once the diffusion takes place and there is a difference in setup and a further diffusion is being stopped. Now let us come to the another topic, which is the PN junction diode, because till now you are very much comfortable about the PN junction. What is PN junction diode? PN junction you know, and here a term diode. What do you mean by this? It is the construction of a term diode, means two electrode. Diode is a two terminal device, two terminal components you can say. There are two electrodes, one is anode and the second is cathode. So PN junction diode has two connections or two electrodes. One electrode of the semiconductor device is known as anode and the other is known as the cathode, and it is one of the simplest semiconductor device, and its important characteristic, its unidirectional behavior. Why unidirectional behavior? Because it allows the direct flow of current in only one direction, right? So its unidirectional behavior, this is very important. You can see this is the circuit symbol over here. PN junction diode, diode two terminal, one terminal is this, second terminal is this, and one is the anode, second terminal is known as a cathode. You can see this particular bar, this represents the cathode terminal. In case if you forgot which is the positive, which is the negative terminal, then with the help of this bar you can recall, bar represents the negative terminal. This is the symbolic representation. But if you go to the laboratory and you are getting a diode, definitely there will be two terminals, first terminal and the second one. But how to identify? Now this is the diode you will be getting in your hand. How to identify which is the positive and which is the negative? Means anode and cathode. Then from that particular component you try to identify at which particular side you are getting a bar. Here you can see there is a silver bar at one side. So wherever you are getting the silver bar, that is the cathode, means the negative end. So this is negative, this is positive, anode and cathode. This is how you can identify the terminals of the diode. Now let us discuss about the biasing of a PN junction diode. What do you mean by biasing? If you are getting a term biasing, biasing means addition of an external DC battery. If an external voltage is applied, see, if there is no external voltage being applied, means you are getting, you are having a PN junction diode and there is no external voltage, it means no bias. Bias means some battery is being applied across that, because there are two terminals of the diode. So battery can be connected in two different ways, right? So accordingly, bias you can explain as the application of the DC voltage. Why? To set up certain operating conditions or when external source of energy is applied to a PN junction. And there are two biasing condition, as I have told you. Since you are getting the diode like in this particular manner, this is a PN junction diode, this is P, this is N. So battery can be connected in two ways, positive negative, negative positive. Accordingly, there are two possibilities of biasing. One is the forward biasing and the other is the reverse biasing. So you have to study about these two types of biasing situations as well, right? Forward biasing of a PN junction diode. What do you mean by forward biasing of a PN junction diode? You must remember, forward biasing means when P type terminal, means P terminal of a diode is connected to the positive and N is connected to the negative. So this is the situation of the forward biasing, means P is connected with the positive, N is connected with the negative condition. So what is going to happen in this particular case? You can see this is a P type semiconductor, N type semiconductor, and you know when a junction, when you are joining and the junction is formed, then diffusion process will take place. Diffusion because of the concentration gradient, and after a certain time a barrier potential is being developed, means a depletion region is being formed. So you can see in this particular case, when you are applying this external voltage V, see the battery polarities have been connected in this particular manner. Now what will happen? This is the positive terminal of the battery, this is the negative terminal of the battery, this is P type semiconductor, this is N type semiconductor. Now what is happening? In case of P type semiconductor, majority charge carriers are holes. In N type, majority charge carriers are electrons. Because of this positive terminal of the battery, holes which are having positive charge, they will be repelled towards the junction. Similarly, in case of N type semiconductor, the majority charge carriers are electrons, and because of this negative terminal of the battery, electrons will be pushed toward the junction and they will cross the junction, will recombine. And if you keep increasing this external voltage, more and more electrons and holes will cross the junction and depletion layer width will be reduced, will be decreased. So this is how you can explain the forward biasing of a PN junction diode. In case of reverse biasing, you must remember here P terminal is connected to the negative terminal of the battery and N is connected to the positive, and this is the situation when a junction is being formed. This is the depletion region when a junction is formed, and when you have applied the biasing, a external voltage is being applied over here. Now see what is happening over here. In this case, since negative terminal of the battery is connected with P and positive is connected with N, and just try to recall, in case of P type semiconductor, the majority charge carriers are holes, while in case of N type semiconductor, the majority charge carriers are electrons. So what is going to happen? Holes are having positive charge. Because of this negative terminal of the battery which is being attached to P, holes will be moving away from the junction, means now they are moving away from the junction. Similarly, electrons which are having negative charge, these electrons will be moving away from the junction, means they are moving towards right. It means now this depletion layer width will increase. But what will happen if you keep increasing this voltage? More and more electrons and holes are moving away from the junction, so depletion layer width is increased. But so one question may arise in your mind, that means in this particular case there is no flow of current. No, here current flows because of the minority charge carriers. See how? In case of N type, there are some holes in minority, while in case of P, there are some electrons in minority. Now what will happen? Because of this applied battery, these minority charge carriers, electrons in P, they will be moving towards the junction, they will be pushed towards the junction, and holes which are in the minority in N, they will also move towards the junction. It means in this particular condition, minority charge carriers are crossing the junction and the current flows because of these minority charge carriers. But since the minority charge carriers concentration is very less, so the amount of current which is flowing in this particular case, that is very less, and the current which flows because of the minority charge carriers, that is known as a leakage current or saturation current. So, these terms you must remember as well, right. There are some important points which I have discussed in today's session. You must remember all of those points. What? See, first you have understand about the PN junction, then we have discussed about the PN junction diode. See, what is a PN junction? A PN junction is a boundary or interface in between the two different semiconductor materials. When you have joined a p-type semiconductor with n-type, then a junction is being formed, then a boundary is being formed, and that is a PN junction. When junction is formed, then what is going to happen? Because of the concentration gradient, the diffusion process takes place. Diffusion means wherever there is a difference in the concentration. In case of p-type semiconductor, the majority charge carriers are holes, while in case of n-type semiconductor, the majority charge carriers are electrons. So, holes are moving from p to n, electrons are moving from n to p. After a certain time across the junction, what is going to happen? Try to recall it. After a certain time across the junction, because electrons and holes are recombined, then immobile ions will be accumulated. From the p side, acceptor ions, from the n side, donor ions, they will be accumulated across the junction, and they will form a layer, a region which is known as a depletion region. Third and very important point, depletion region, this is also known as a depletion layer, depletion zone, depletion region or space charge region, right, because it contains positive and negative ions. Because of the presence of immobile positive and negative ions, a restraining force is set up across a junction which will further stop the diffusion. This is known as a barrier potential. You must remember it, barrier potential. Second thing, we have discussed about the PN junction diode. PN junction diode has two terminals, one is anode and second is the cathode, and PN junction is the basic building block for any electronic devices. And there are two possible types of biasing, I must say, are possible in case of PN junction depending upon the manner in which the battery is being connected. Biasing is the addition of an external battery. So, if P terminal is connected with the positive, N is connected with the negative, means the forward biasing. If P is connected with the negative, N is connected with the positive, means the reverse bias. So, this is how two types of biasings are possible. So, you must remember all of these points, these are very important. Thank you so much.